What's up, guys? Today we are going to be talking more about Lewis structures and the actual composition of atoms and how they actually bond together. So first of all, we need to know about formal charge. But first of all, before that, we're going to need to know about covalent bonds. So basically in covalent bonds, they're when one atom comes and he says, hey dude, I'm missing an electron. Do you have one? Yeah, but I don't really want to give it. Oh, then maybe we could share it? Yeah, great. Then we'll both have a full valence electron shell. That's actually what happens with hydrogens. Because hydrogens, let's say, each hydrogen atom has one electron. So here's a hydrogen, and he has one electron. So does this guy. So, hello, I'm missing an electron. Would you mind giving me one? No, because then it'll be, well, I'll just be an ion, and I don't like being an ion. Oh, I don't like being an ion either. Then maybe we could share it. Yeah, great. Then we'll both have full valence electron shells. And then, here comes the bond, and they stick together, and they live happily ever after. It's a diatomic hydrogen molecule. That's how it works. And those are covalent bonds. So purely covalent bonds have no difference in electronegativity, like if it's the exact same element. Polar bonds have a difference in electronegativity, but not enough such that one steals the electron from the other, or one gives the electron to the other. That's when it's ionic. Next is the formal charge in a covalent compound. So the formal charge is going to be equal to the number of valence electrons as a normal atom minus the lone pairs, and then minus 1/2 times the bonding, or the ones that it's bonding with, the ones that it's sharing with the other molecules. So now let's go look at nomenclature. So for ionic solids, it's pretty straightforward. The name of the metal and the name of the non-metal base with an "ide", such as sodium chloride. Sodium's a metal, so we put it first. And then chlorine is the non-metal. Well, chlor is the base, and we add "ide" to the end, becoming chloride, so it's sodium chloride. Similarly, sodium fluoride, calcium fluoride. However, for water, it's actually dihydrogen monoxide, even though in calcium fluoride there are 2 fluorines for every calcium. We don't use it. That's because it's different between ionic and covalent. For covalent, we use the Greek prefixes mono, and mono with its mono and oxide, it will be monooxide. It doesn't make a lot of sense, so we make it monoxide to make it pretty straightforward. But now next, so we use Roman numerals for transition metals in ionics. We haven't gone over that yet. Let's go back to the Greek prefixes. So listing them out, it's mono, di, tri, tetra, penta, hexa, and then hepta, and octo, nona, and deca. Those are the prefixes. Pretty straightforward. You can look them up on Google. But next of all, we come to ionic solids with transition metals. For example, we have iron 1 chloride, and iron 3 chloride, and iron 2 chloride. How do we know? How are they different? Well, that is the metal's charge. Like in iron 1 chloride, the iron has a positive 1. In iron 2 chloride and iron 3 chloride, they have 2 and 3, respectively. So that's the difference between them, and that's why we put them in Roman numerals, like iron 2, or 3, or just simply 1. If it's 1, we still need to put 1. Iron 1 chloride. Whatever, I'm not going to write it, but anyway, next, let's look at Lewis structures. Lewis structures are very important and will become a lot more important later into your study of chemistry. So hopefully now you've got Lewis structures down. If not, I'm here to teach you. So here, Lewis structures. Lewis structures. So first, simply drawing them for an atom is pretty simple. And another rule that atoms generally like to follow is that they like to have a full octet, except for transition metals, which are pretty much fine with everything, and giant atoms, which are also pretty much fine with everything. And also with the exception of hydrogen, which really wants to form di. It's not going to have 8 electrons because it's so tiny. Same for helium, but helium doesn't really form bonds, or does it? Yeah. Well, anyway, let's draw it for hydrogen. So each hydrogen has 1 electron in its normal state. So here are some hydrogen atoms. We put that 1 electron like right there next to it. Alright, now let's say they come together and they want an electron from each other. They want to share it. So in that case, we would put them like this between them. And this, if it's between 2 atoms and it's being shared, is the equivalent of this, a bond. Next, let's look at oxygen, which forms a double bond. Each oxygen has 2 electrons ready to share. And the oxygens are willing to share both of them to make it stable, because then they'll both have full octets. Otherwise, they both only have 6 electrons with 2 electrons to share. So they share them in the middle right here, like this. And each of these is equivalent to a bond. So that one's a bond, so is that one. Alright, next one, let's do nitrogen. Nitrogen has a triple bond. So nitrogen, each nitrogen has 5 electrons, but they only have 3 that they want to share, because their 3 are their valence electrons. And let's say they want to form a bond together. So since I drew the nitrogens too far apart, I'm going to redraw them like this. There. Now each of those double dots is going to be a bond. So, triple bond. And also the theoretical carbon has a quadruple bond, but we're not going to go over that now. That's all you need to know about Lewis structures. Resonance structures we can cover later, but they're not really necessary. I will have a special video posted about that also, but anyway, see you in the next section. We're going to be discussing molecular orbital theory, which is a little more complicated, but I'll teach it to you and you'll get it down. If you want more, or you have a test coming up where you could use some practice problems with easy-to-follow, step-by-step solutions, then I have some videos that I use with my tutoring clients, but you can get them for free. All you have to do is subscribe, send me an email saying you subscribed and specifying which video you want, and I'll send it to you. Alright, bye! Thank you!